Hello class, and thank you for watching the video on domain and range. In this lesson, you will learn how to domain of a continuous graph. We to right and identify again the x values that quote unquote touch the graph. And for the range, we scan again, but in a vertical direction from down up, and identify all of the y values in which you again are quote unquote touching the graph again with your pencil. So for example, let's look at example number 1. Let me draw a vertical line here in red. Draw a vertical line here in red. Okay, you see that vertical line right there in red. If I was to slide that again from left to right, notice that the graph touches this red vertical line somewhere while I scan from left to right. Okay, now the arrow indicates that the graph continues moving to the right and also continues moving to the left. So for this example right here, the left and right side of this graph has no boundaries. So we're going to continue moving to the left, and this vertical line is going to move more to the left, eventually going all the way to negative infinity. And then the same thing in the opposite direction. The graph is going to continue moving to the right, again going all the way to positive infinity for the values of x. So here, again along the x-axis, negative infinity on the left. The domain of this thing is going to be all of the real numbers from negative to positive. So another way of thinking about this is thinking about how far the graph reaches from left to right. Well, the farthest point, like I just mentioned, that the graph is going to reach is negative infinity, because it's going to keep on curving up and down, and positive infinity to the right, because the graph is going to keep on curving up and down. So because of this, the domain, the values of x, are going to be any number between negative and positive infinity. And because the infinities cannot actually be reached, we do not include those as numbers that we actually use for x. We use open parentheses, as you're seeing right here, the regular parentheses, open parentheses, to indicate that idea there. Now, for the range, we just simply think about it the same way, just in the opposite direction, in the vertical direction. So let me draw a vertical line here. Sorry, horizontal line. There we go, horizontal. And if I start sliding this horizontal line upwards, notice that it starts touching the graph here and continues touching the graph until I reach a maximum height here. So in terms of the range is bounded. The domain is not, because it goes from negative to positive infinity, but the range is bounded, and it's bounded between -4 and +2. So the highest the graph is going to reach is this vertical line here, and the lowest that the graph is going to reach, horizontal line, and the lowest that the graph is going to reach is this horizontal line there, which is the value of -3, not -4, I'm sorry, I misspoke earlier, and +2. So this graph is bounded in terms of the y value, -3 and +2. So that tells us what the range is. So our range is going to be the y values between -3 and +2. Now, because the top boundary and the lower boundary, again, are not open circles, that means that they are included within the set, and we use the brackets to indicate that. So let's move on to the second example. Let's do more examples. All right, so for the second example, again, we think about this the same way. So vertically, so from left to right, we draw a vertical line and think, okay, what's the farthest left that this graph is going to reach? So if I look at this right here, and I start over here to the very far left, you notice that the graph doesn't exist all the way to negative infinity, even right here to negative 6. It starts to exist when we get to that point there. And then again, this vertical line keeps touching pieces of the graph until we get to this endpoint here. After that endpoint, the vertical line, the red line, doesn't touch the graph. So this graph here exists between these two red lines, between that red line there and this red line on the left. Well, the x values here, the x value of this red line on the left is, well, since this here is 0, this is 0, this is 1, 2, 3 units to the left of 0, so that's negative 3. And this one is 2 units to the right of 0, so that's positive 2. So the domain of this graph here is all of the x values between negative 3 and positive 2. Now, since the endpoints at those locations are open circles, we use parentheses to indicate that. For the range, we do a similar process, but now vertically. So this horizontally. So we go from left up to down to up, in a vertical direction using a horizontal line. So from this situation, notice that the graph doesn't exist down here, neither here at this negative value. It does exist there. We start touching the graph right here, and then units higher than that. We're still touching the graph. We're still touching the graph at this point there, but notice that the graph still is being touched by this blue line as I move up, and the farthest up that this blue line touches is up here. So this graph exists between the following two blue lines. The blue line down here that I'm drawing again, and this blue horizontal line that I stopped it at. Well, the blue horizontal line down here, let's count from 0 is 1, 2, 3, 4, 5. So negative 5. And this blue line up here on the top, that is positive 1, 2, 3, 4. Y equals 4 and y equals negative 5. So from down going up, the range of this thing is all of the y values from negative 5 to positive 4. At positive 4, we see that the graph ends up here at this open circle. So we're going to indicate that by using the normal parentheses. But down here, the graph begins down here. Again, this horizontal line touching this point right here. That is a closed. It's not an open point there. This is a closed point. So at 5, we're going to indicate that at the y value of negative 5, that's a closed point. So we use the brackets, the closed parentheses, which is the AKA brackets. Let's look at more examples. Let's look at this quadratic that's on its side. So for this example, let's again start from left to right. Well, from the left part, let me just draw the vertical line right here. And I'm just using this as my little guidance point there. So if you look at this, notice that there is no left boundary. Okay, the graph is not going to stop here. It's going to continue moving to the left, moving to the left, moving to the left. So there is no boundary to the left for this graph. So this graph is eventually going to go all the way to negative infinity. Well, from left to the right, the graph again is still touching the graph, continue touching the graph, continue touching the graph into this point here. So the left end has no boundary, but the right end does. The right end stops here, where that vertical line is located at the x coordinates of positive 2. So the domain for this thing is going to be all of the x values from negative infinity to positive 2. And since again we can't technically reach negative infinity, we use an open parentheses and regular parentheses right to indicate that's going to be open on the left end, and because it's unbounded. But on the right end, it's bounded by 2. The graph does not exist any further than 2. and because it is not an open endpoint, there's a closed point there. We're going to use a closed bracket. Now the range is interesting because the range has no bound. The graph is not going to stop at this y value here of -2 or -1.2. It keeps going further and further down. So there is no lower boundary. And the same thing is true with the upper boundary. This is not the highest point that the graph reaches. Again, even though it's pointing towards the left, it is still pointing upwards. So the graph is still going to move upwards. So there is no upper boundary and there is no lower boundary. And because there are no boundaries, that means that the range of this thing is going to be all the real numbers. So from -infinity to +infinity. So again, when you compare the left and the right, and you compare again the first three problems, whenever there is no boundary, so it's not going to stop there. So it's not going to stop at this left point, and it's not going to stop at this right point. So there's no boundary at all. So that means that my range is going to be -infinity to +infinity, and the same thing is true with the range. There's no lower boundary, there's no upper boundary, so the range is also -2. Curves and reaches this relative minimum, a maximum, and this relative minimum, but the graph continues moving up to the far left and to the far right in those respective manners. So on the far left, the graph is continuing moving to the, even though it's pointing downwards, it's continuing moving to the left a little bit. Okay, it's going to continue moving again to the left, and the arrow indicates that it never stops moving to the left, the same thing as up here. So there is no boundary to the left or to the right. So the range, just like the previous one, is all real numbers. And the same thing is going to be true with the range. There's no lower boundary, so the graph is going to reach all the way to -infinity, and there's no upper boundary up here, so that's going to reach all the way to +infinity. So there is your range. Now the next one is an interesting one, because here, just like the last three, the domain has no boundary. There's no there's no endpoint on the left and no endpoint on the right. So your domain is all real numbers from negative to +infinity. However, your range is bounded. There is a boundary to your range because this is your line, this horizontal line right here. The boundary for the y values is only -4. 1, 2, 3, 4. -4. Doesn't matter where I find the point. The y value here, let me do them in yellow, here, 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 anywhere, your y value is always going to be -4. So for this entire horizontal line, that is going to be your range. So for this next example, for the next three examples, let's look at the circle. Well, these are, circle is bounded. For the range, the boundary are these two vertical lines. I'm sorry, for the domain. For the domain, I said a range. I meant to say domain. For the domain, these two vertical lines are the boundary points for the domain. The circle doesn't exist to the left of the far left vertical line, which is at x equals -3, and the circle doesn't exist to the right of the right vertical line, which is at x equals to +3. So the domain of this thing are all of the values from negative to +3. And again, since there is no open circles at those endpoints, there's going to be a closed brackets. Now for the range -3 upper boundary of y. So your range vertical direction, negative through +3. Now let's look at the diamond. The diamond again is also bounded for the domain and the range. The farthest that the diamond reaches along the x values is no further than this vertical line, which is the line x equals -1. And the diamond doesn't move any further than this vertical line, which is x equals 5. So the domain of this function are all the x values between -1 and +5. And again, it's a closed interval on both ends. Now what about the range? Well, the range again is also bounded because the diamond doesn't go any lower than this horizontal line, which is at y equals to -3, and does not go any higher than that horizontal line, which is y equals +3. So my range are all the y values between negative and +3. And again, it's closed. And finally, for the last one, for this V-shaped graph, the domain is unbounded on the left side because of the arrow. Again, it's going to continue moving to the left, and unbounded on the right side. The arrow is going to indicate that it's still moving to the right. So since there are no boundaries on the left or right, that means that your domain is all real numbers. So from negative to +infinity. Now the range is bounded on one side. On the lower end, it's bounded by this vertical line. The graph does not exist. The function doesn't exist any lower than the vertical line y equals -2. However, upwards, there is no boundary value above that. It doesn't stop here, nor does it stop here. It continues moving upwards. So there's no boundary point up here. So the interval here would be from -2 all the way up to +infinity, because there is no upper boundary. So we're going to go all the way to +infinity. So -infinity to +infinity is the domain, and your range is from -2 to +infinity. Now at -2, that's a closed endpoint, so you're going to use the closed parentheses, which is the brackets. And of course, with the infinities, those are always open, so you can use the regular parentheses. And there are your examples on how to determine the domain and range of a continuous graph. Okay. Well, again, thank you again for watching. If you have any questions, please send me a message through my email. And like I was saying, again, I appreciate you watching. Send me a message through email if you have any more questions or get stuck on any of the assignment problems. And like always, I hope you have a great day. Goodbye.